Hello guys, my name is Khan Hidatullah and today I'll discuss about feed-forward networks in artificial neural networks. So the first question is, what is feed-forward neural networks? So the definition of feed-forward network, or the simple concept, is that these are artificial neural networks where the connections between units do not form a cycle. There are no cycles between the units. These are the units. What are the units? All these units, they they are the units, and they are also known as neurons. So they are called feed forward because information only travels in the network there where there are no loops. Because if there is a loop, that means there should be information would come here, and then from here it will go back. It will create a loop. But here in this, there are no loops. First through the input nodes, then through the hidden nodes, and finally through the output nodes. There are no loops. You can see that this, let's say x1, it comes here, and from here, let's say y1, it comes here, then it comes here, finally the output. So in simple words, a feed-forward network is simple neural network. The term which we have heard the most is basically a collection of neurons, and these are all neurons, is x1, x2, x3, x4, and xn. They're all neurons. So now each of these neurons, or each of these layers, they have specific names. The first layer, which is this layer, it is known as input layer. And the intermediate layers, these two layers, which these are known as hidden layers. And there could be multiple. There could be one, two, and so on. There, there could be many layers in hidden. So if hidden layers are more than one, we call them deep network. So if there are more than one, the hidden layers, we call them deep network. Now that's where that's from where the name comes, which we call deep learning. All of this we are studying is basically the deep learning. So the the final layer which we will talk about is output layer. This layer, this is an output layer. Now the question here is how these input layer sends data to the hidden layers, and then from hidden layers to the output layers. How does it happen? So the way it happens is that the feed forward network, it uses active functions. It uses active functions, and those active functions are then they decide which neuron should be sent forward and which neuron should be left behind and not sent ahead. Let's suppose there's one, let's say two, this one neuron, it gets these two, three, and there is one we called bias. So we also know that these three, all of them are coming to this neuron. This neuron can be written like this. This neuron can act like where there is one linear function, when one is the combination of linear and nonlinear function, it can make an active function and then it sends it out. These can be A0, A1, A2, function. So now we will discuss about the functions these deep forward net feed forward network use. Let's talk about the first function. The first choice is sigmoid activation function. Sigmoid activation function. So it takes this form, which will not, which we will note it as this acronym SIGM, and it can also be uh, represented it as the symbol, sigmoid symbol. And it takes this input activation, which is also known as pre-activation or input activation, and compute this formula, which is 1 over 1 plus exponential of minus a minus input activation. So we know that you can see, as you can see from this uh, this graph, that when we draw this function, what we see is that it will squash the neurons of the input activation between 0 and 1. What does that mean? We see that all output values are between 0 and 1. See, 0 and 1. All the output values are between 0 and 1. And so the bigger the input activation, the more it will saturate towards 1, and the smaller the activation towards minus infinite, the more it will situate towards 0. The other function of this activation function is that uh, it it is always positive. It's strictly greater than 0. It's bounded. Why is it bounded? That it's the output of the neuron. The activation of the neuron cannot be smaller than 0. The activation cannot be smaller than 0, and nor greater than 1. So we can see here it cannot be smaller than 0 and nor greater than 1. So it just here and here. And the other thing, this neuron, this function is strictly increasing. It is always strictly increasing. That is, the bigger the input activation, the higher the activation of the neuron will be. So this is all about the sigmoid function. Now let's talk about the other function, which is known as hyperbolic tangent, or 10H, the acronym 10H for short. Uh, this function, when you plot this function, we see that when we plot this function, we see that we get an output which is constrained between -1 and +1. So it is constrained between -1 and +1, and it squashes the neurons input activation between -1 and 1. So it can be positive or negative. It's also bounded. It's also bounded similarly like uh, sigmoid activation function, and it's strictly increasing like the sigmoid activation function. The next function, which is widely used in uh, deep learning, it is known as rectified linear activation function. This function is what we call Reclined function, for short, Reclined, uh, and it's simply the maximum between 0 and the input activation. The maximum between 0 and input activation. Uh, and so if you plot it, this the plot. If you plot it, we get a straight line, and we get this straight line here, and a line like this, like a linear, uh, like linear function, but it is actually non-linear function. And if the input is positive, if the input is positive, we get we get then it's greater than 0. We get the value which is greater than 0, which is greater than 0. And if the input is less than 0, in minus, we always get 0. The other thing is it's not upper bounded, because the greater the input activation here, the greater the input activation, the greater the output will be. And it's also strictly increasing like the other functions. But there is a big difference. We see that it tends to give neurons that are sparse, which means it has sparse activities. What we mean by that is it tends to get neurons that are often exactly 0. We the neurons which are exactly 0, which were, and this is not the case for the sigmoid and this the tangent uh, function. So this is all about the deep forward network, feed forward network